Good evening. We're going to do a quick little video here for section 5.2. Again, it's very much related to section 5.1 that we did last week. Last week we worked only with the standard normal distribution, meaning we were doing all of our calculations based on z-scores. Section 5.2 talks about normal distributions, and now it wants to actually utilize x values. Now there's a couple ways you could do this. The first would be to take your x values and some given mean and standard deviation and convert your x values to z-scores, and then go use the table that I linked to, or other similar tools to find areas or percentages or probabilities under the normal curve. Our technology tools allow us to bypass that step. You could do it in a TI-84. You could do it in Microsoft Excel. We're doing it in Google Sheets because I know it's available to everyone. Again, keep in mind we're going to use this normal distribution function that we used last week. Last week we input the z-score, a mean of 0, and a standard deviation of 1. And again, the word true, because that's what tells the calculator, or the Google Sheet in our case, to do a cumulative area. So this week we're actually going to input our x value, a mean and standard deviation that are given to us, and the word true. Remember, normal distribution always calculates cumulative area on the left-hand side of your normal distribution curve. That is from negative infinity up to the x or z value that you choose. If you want to find the area to the left of an x input, you're going to do normal distribution, x, comma mean, comma standard deviation, and the word true. If you want to find the area to the right of an x, we're going to input 1 minus the normal distribution. That is, we're going to calculate the area to the left of our value. We're going to subtract it from 1 or 100%. And finally, to find the area between two x values, we're going to find two normal distribution areas and subtract them. We're going to start by finding the larger area using the larger x value. We're going to find the smaller area using the smaller x value, and we're going to subtract those two areas. So take a quick look at an example here. This is number 14 on page 233 in your textbook or in the PDF document that I shared. Atlantic croakerfish have a mean length of 10 inches and a standard deviation of 2 inches. Find the probability that a randomly selected or randomly caught Atlantic croakerfish will have a length of less than 7 inches. So we have x is less than 7 inches. Letter B says between 7 and 15 inches, so x is bigger than 7 but smaller than 15. And finally, a randomly selected fish is greater than 15 inches, so x is larger than 15. I already have our inputs written down here. Less than 7 is going to be normal distribution, 7, 10, 2, and the word true. So let's give it a shot here. Equals normal distribution, 7, 10, 2, true. And if we did this correct, the textbook here says that the answer is 0.0668. 0.0668. And again, I changed my format on these ones where I knew the solution was going to be up under format. I changed it to 4 decimal places, so it rounded it automatically to 4. Our next one, between 7 and 15 inches. So we're going to have to type this all out here. Equals normal distribution, larger x value, which is 15, mean of 10, standard deviation of 2, and the word true, minus our second normal distribution, 7, mean of 10, standard deviation of 2, and again the word true. And if we did this one correct, we should get 0.9269, somewhere like that. 9270, rounded up, okay. And lastly, greater than 15 inches, we're going to do equals 1 minus normal distribution, parenthesis, 15, 10 was our mean, 2 was our standard deviation, and the word true. And we should get a solution on this one about 0.0062. Bingo, we got it. So Pretty straightforward, almost exactly like what we did last week. The only difference now is that we're actually going to plug in x values and means and standard deviations instead of z-scores, 0 and 1 for mean and standard deviation. So really not that much different than last week. I think I said last week that if you took the time to learn it, it was going to make this week really, really easy. And I think that's true. You're just inputting some different numbers in here. But all of these facts about how you calculate area to the left, area to the right, or area in between will all be the same this week as they were last week. So I hope this is helpful. Should be a quick and easy assignment for this week. And shoot me an email or use the Q&A docs whenever you get a chance. If you have any questions, let me know. I'm happy to help. Have a good one.